Hi, welcome to this course. This is Muhammad Yaqub. I am the founder of Scratch. In this project, we are going to learn about AI-based face mask detection using Yolo V11. So we all know that whenever pandemic is happening, so wearing mask is essential thing. So without that, we will be responsible for spreading the disease to the innocent people. To identify who are the people already wearing the mask and who are not wearing the mask, we have came up with project called AI-based face mask detection. For this, we have collected lot of custom data sets, some group of data sets for face mask with face mask and a group of data set for without face mask. And then using Yolo V11 architecture, we have custom trained the complete data set, and then we have used Tkinter graphical user interface. So when we upload the videos, then that will be captured and will be notified with the help of Tkinter graphical user interface. So this is the overall theme about the project.
I'm going to give a brief overview of the project. The project is called Face Mask Detection, and in this project we will detect whether a person is wearing a mask or not using the advanced Yolo 11 model. We will train this model on the Google Colab platform using a custom dataset, which we will collect from the Roboflow website, including both masked and unmasked images. Once the model training is completed, we will perform inference on the VS Code platform and display a live stream in a Tkinter window. This is a brief overview of the project. Next, I will show how to train the model on the Google Colab platform. First, you need to go to Google and type Google Colab. Welcome to Colab. Then you need to upload here. Click upload. Then you need to drag and drop the mask detection.ipynb file here. It's opening now. Now the mask reduction IPNB file has successfully opened on the Google Colab platform. Google Colab is an open source code development platform created by Google, and it is especially used for machine learning and deep learning model training because the GPU is free for up to 6 hours. After that, it will be disconnected. Then it will only be reactivated the next day. And most of the libraries and packages are already installed on Google Colab, so we don't need to install them from scratch. We can just import the library and use it. And then I'm going to connect with the notebook with the T4 GPU. Now the notebook is connecting to the Python 3 Google Compute Engine backend GPU. They need to open files. Now the notebook is successfully connected with a T4 GPU, and I'm going to show manage a section. Only one notebook is active here, the notebook with GPU. And then first you need to mount Google Drive, which makes it easy to store files and access files from Google Drive. First you need to connect to Google Drive. Then choose an account. They need to continue. Then scroll down. Then continue. Now Google Drive is successfully mounted. So I'm going to install Roboflow. Now the Roboflow library is successfully installed on the Google Colab notebook. The Roboflow version is 1.151. They needed to import Roboflow from Roboflow. Then define an API key in the Roboflow class. set the workspace name to Joseph Nilsson and the project name to mask wearing. This is the dataset name, and then we are going to download version 19 of the dataset, and we will download it in Yolo 11 format because we are going to train using the Yolo 11 model. Then I'm going to execute this cell. Now the dataset is downloading. Now the dataset has been successfully downloaded. Mask wearing 19. This is the folder name which contains the test set, training set, and validation set, as well as the data YAML file. The data YAML file includes the paths to the train, image and validation, image folders, the number of classes, and the class names, which are mask and no mask. Next, I'm going to make some changes to the data YAML file. I'm going to delete the test path, and then we need to remove this existing path as well. Then you need to copy the path of this images folder, paste it here, and also get the validation images folder. Then copy and paste its path here as well. Finally, save the file. Then close it. Randomly visualize dataset images in the training set folder. First, we need to get images from this folder. The folder name is train images, and get the paths using paths from immutils. Then define a Python function. The function name is display images, and you need to call this Python function. They need to provide arguments. The arguments are image paths, title, and the number of images to display, which is 25. Then image paths, title, columns is 25, and the number of images is 25. Then shuffle the dataset images and get the minimum number of images to display. Next, set the number of rows and columns. The PLT figure size is 12 by 12, and then set the PLT title. Then iterate through the images one by one using a Python for loop with enumerate. Then use PLT subplot. Then open the image, convert it to grayscale, set the PLT title, turn the axis off, and finally visualize with PLT show. Next, I'm going to run this cell. Now the cell is executing. This is not a mask, and this is not a mask. The person is wearing a mask but removed. The person is wearing a mask, not wearing a mask. Then install the Ultralytics library, which is used to train the Yolo model, and I'm going to run the cell. Now the Ultralytics package is being installed. The Ultralytics version is 8.365. Next, you need to download the pre-trained Yolo model. This model was trained on up to 80 classes, and we are going to use this base for Yolo. I'm going to give a brief overview of the Yolo 11 model. Yolo 11, which stands for You Only Look Once, was implemented by Ultralytics, and the model was trained on 80 real-world object classes. Previously, there have been many different versions available: Yolo v2, Yolo V3, 4, 5, 6, 7, 8, 9, 10 and 11 with the very latest version recently released by Ultralytics. The performance of this model is better compared to previous Yolo versions. Its accuracy has also improved and the number of parameters has been reduced from those in earlier Yolo models in particular. In Yolo 11, there are up to 24 convolutional layers and 2 fully connected layers. And finally, the output is obtained using a linear activation function. Next, I am going to train the Yolo 11 model using the pre-trained Yolo 11 model weights. Using Yolo train, we define the pre-trained model weights, then specify a data YAML file here, and we are going to train for up to 100 epochs. If you read the book once, that is called one epoch. If you read the book 100 times, then it is called 100 epochs. Then with images of height 640, I am going to start training. Now the model has started training. Here is the parameter information and it has been set for 2 classes. This is the layer information of the Yolo relevant model. This is the convolutional layer which is used for feature extraction. Then finally it outputs things like the bounding box, confidence score and the class name as an integer. Here you can see the training and validation dataset information. The dataset loader worker is set to 2, runs detect. Train 2 is used to store the model weights and graph information. Now the first epoch is completed. Initially the map value is 0.23 and the map at 0.5 score is 46. The model is currently learning very well in this initial stage. Once the model completes up to 100 epochs, the model's accuracy will be above 70 map and the loss will also be reduced compared to the initial stage. So we need to wait until the training process is complete. Once the model is finished, we will be able to make inferences using this model. The model training has been successfully completed up to 100 epochs and I achieved a precision of 0.94, recall of 0.84, MAP of 0.93 and MAP at 0.5, 0.95 of 68. This is for mask and no mask. And then the model weights are stored in the runs folder under detect, then train to as best PT. This is loss PT. Whenever the MAP increases beyond the previous value, the best weights will be saved as best PT. This is the loss PT for 100 epochs. Then there are the phone score, precision recall score, precision recall curve, the arguments, confusion matrix for mask and no mask labels, and the results, then training batch images and validation batch images. Next we are going to see how to perform inference using the trained Yolo relevant model on the VS Code platform. To perform inference with the trained model, you need to download the best PT file from the folder. You need to open runs, then detect, then open train 2, then select the weights folder and then download best PT. Now it is currently downloading and it has now been successfully downloaded. After that, we can move into the newly created Google Drive folder, and then after making sure that everything is properly in place and ready, I'm going to execute this process. The folder has been successfully created on Google Drive, and now I'm going to move on. Next, I'm going to create a new folder on Google Drive to store the results in that folder. Then I'm going to execute this cell, and then we need to wait a few seconds for the moving process, and it has been successfully moved to the drive mask reduction project folder. So we are going to see how to perform inference using a TriNet Yolo 11 mask reduction model, and the base PT file must be present in the face mask reduction folder. Then you need to open CMD here. Next, you need to type code space dot here, and it will redirect you to VS Code. Now the project folder has been successfully opened in VS Code. This is the input video folder, which contains two folders, one for mask and one for no mask. We are going to perform inference using these two video files. Then there's the mask image folder, which is used to store mask images. Next is base PT, which is the TriNet model weight file we will use for inference. And we have two classes. One is mask and the other is no mask. This is the inference code, which includes inference functionality implemented with the Tkinter GUI. Now this is mask deduction IP number 5, which is used to train a custom dataset using the Yolo 11 model. This is the requirements. TXT file, which we will use for inference, the Ultralytics library, and then sort, which is used to assign a unique ID to each detected mask. First, I'm going to explain the code for the project, and then I'll show how to execute the code. These are the necessary libraries for implementing the project and performing inference. The packages include CV2, which is used for image processing and image handling. Then for sort, we have a set of code that is used to assign a unique ID to each detected object using the IOU technique, which refers to overlapping. And then NumPy, which is used for handling RF data. Then we import the message box from Tkinter, which is used to display text in a Tkinter window using a message box. Sys is a basic Python library that is used to exit the execution. Next, we import Ultralytics, which is used to perform model inference using the trained model, and then obtain the output for the bounding box, class score and confidence score. And then CV zone, which is used to draw rectangles in the OpenCV window. Then regular expressions, which are used to remove some unwanted text from strings. Next, OS, which is a basic Python library used to handle basic operations such as getting files from a folder. Then Tkinter, which is used to implement the graphical user interface. Then TTK is imported from Tkinter. Then field dialog. Pillow is a Python library used for image processing and image handling. In this project, we will use it to enhance image quality using image enhancement techniques. Threading, which is used to perform multi-processing tasks. Then import date and time from the datetime module. Then TK, CSV. CSV, which is used to handle CSV file data. In particular, we will use this library to download mask reduction information in CSV file format. Shuttle, which is used to copy files. CV2, which is used for image processing and image handling. Then we have two variables. The name of the variable is running. Initially, the program has not started executing. At that point, running is set to false. Also, the video path is not selected at first, so it is set to none. Next, there is mask rows, which is used to download data in CSV file format after the inference is completed. Then, create a new folder to store the mask images. This is the save as CSV file function, which is used to download data in CSV file format. You need to provide the data, the address, and the file name. The file format used is CSV. This specifies the file extension, and if no file path is selected, the function returns. Next, this is the file that we are going to write to at the specified file path using a CSV writer. Then we write each row one by one by iterating through the data and writing each row. Then finally display a message indicating that the data was saved successfully. If any error occurs during this process, use a try except block to show an error message box with show error. Fail to save as CSV file format. Mask data is primarily used to store unique data, especially unique mask IDs. It utilizes a set data type, so it does not store any repeated object IDs or data, and it only allows unique mask IDs to be stored. Then you can access mask rows and mask data using a global variable, which conveniently allows access from a local variable too. If the user did not provide a video path, display an error message. Please choose your video file. Next, load the best RPT model using the Ultralytics library. Then use CV2, video capture an OpenCV function to input the video path and retrieve frames from this variable. Then append the class names to this cod class names. Next, read the class names one by one. Then define a tracker with several important parameters: max age, min age, and IOU threshold, which determines the confidence for a particular object ID. If it keeps tracking the same object, the ID will not change. Then obtain the width and height of the video frame. Initially, the count is set to 0, which is used to assign a value in the image path, while true, which means the loop keeps running until the frame becomes empty. Then use cap. Read to read each frame one by one and store it in the frame variable. Ret is either true or false. If there is a frame, then ret is true. If a frame is not available, then ret is false and the execution stops. So we want to display a frame in the created window. The image size can have various resolutions, but if we want to display it in the created window, we need to set a specific size for the frame. That's why we define a specific size, which is 800 for the width and 450 for the height. Then the frames are fed into the model class, which is used to make inferences using a trained model, and then we get the output from the model. The outputs are the bounding box, confidence score, and class names. And this is the variable used to store the bounding box and confidence score. Then there's a for loop, which is used to iterate through your results. The mask detections variable is used to obtain the bounding box information. Next, you iterate through your results using a for loop, then get the bounding box coordinates such as x1, yone, x2, y2, and convert them into integers. Then you get the confidence score of the object and the class name as an integer, which will then be converted into a string. We are going to use this data if the confidence score is 0.5. Only then can we truly determine whether it is a mask or no mask. Then the mask box is passed to the tracker, which is used to assign a unique ID to each detected object. Next, you iterate through your results one by one using a for loop. Then you convert the bounding box coordinates to integers. After that, you obtain the ID of the object, CV2. Rectangle is an OpenCV function used to draw a rectangle using the bounding box coordinates. This is the starting point of the bounding box and this is the ending point of the bounding box coordinates. This specifies the color and this is the thickness. Then CV2 put text is a function used to display text in an OpenCV window. The arguments are the frame, the status, either mask or no mask. Then the mask ID, the position where the text should appear in the OpenCV window. Then the font name, font size, color and thickness. This is the if condition. If the mask ID is not in the mask data, then add the mask ID to the mask data set. This does not allow any duplicate data. And then this part is used to crop your region. Then we use the image enhancement technique. This is the pillow library, which is used to enhance images by adjusting brightness, contrast, and sharpness. And we have to provide some values to this function 1.2, 1.4, 2.5, then save the image, then create a current timestamp. This is the image path and then mask reduction. It is a function used to display a mask ID, object detector, and the current line image path in a Tkinter window. Then mask rows are appended to a list which is used to download the data as a CSV file format. This is all the data. Then convert the frame from BGR to RGB. Generally, frames are referred to as BGR. If you want to use that frame in Python, you have to convert it to RGB, then get it as an array format, then use image TK, photo image, which is just for displaying a frame in a Tkinter window. Then store the image in the TK video label, apply different configurations, and then update the route. Once the frames are processed successfully, release all processed frames and destroy all OpenCV windows. Start mask deduction. It is a function that is used to stop the program execution and it is already defined with running set to false. Once the program execution has started, then the running variable is set to true. Threading is a library used to access shared resources across different functions. Stop is a function that is used to halt execution once the user has exited. Global running is true, then now set to false, then sys exit. Choose video file is a function used to select a video file from a folder using a Tkinter window. A user can use MP4 or any other file type. If there is only a file path, then store the file path in the video path variable. Load image is used to read the image and then resize it. The arguments are the image path and the image width and height are 50 by 50. Then open the image using the pillow library and resize it to our required format. Then finally return the image in Tkinter format. Download image is a function that makes it easier to download images as PNG files or in any other file format. Then, if the path exists in the save image variable, copy the image and then download the mask information data as a CSV file. Then mask reduction, which is to display here specifically the object ID, the date and time, the object itself, as well as the mask image path. First, I needed to insert into this intuition list, which is used to load the image using the pillow library. Then update the image in image refers. Then the label, which is to displays the text here, and this is a button. So the user can, for example, download a CSV file. Then define Tkinter as root. The title is face mask reduction and the Tkinter window size is 600, which is resizable. Then style configuration, Arial 12, Arial bold, and Arial 10. This is the Inference notebook, which is just used to display a frame. Video frame, live video. This is the log information, the mask log, which is used to display mask information. Tkinter log tab. Then the background is white on the right image button. Then image refers is defined in dictionary format. Then the label is AI powered face mask detection, Arial 18 bold with a black background and white foreground. Then packed. Then this video frame is used to create a new column specifically for the Tkinter log interface. After that, the heading for this column along with the column itself are both stored together into an intuition list for later use. Finally, both the heading and the column are carefully packed into the appropriate location within the interface. A download mask reduction button is created specifically for downloading log information. Then this button frame is carefully packed, and then the user has to select the option choose video file, for which a separate button is also created. Then the start button, root.main loop, which means Tkinter runs continuously. Next, I'm going to demonstrate the code execution for the project. First, you need to open the terminal. Go to terminal, then select new terminal. First, you need to install the required libraries using the requirements txt file. Then you need to type here pip install our requirements txt and press enter. Now the packages are being installed. Next, execute the inference py file. You need to get the path to this file, then paste it into the terminal as Python inference py. Now the code execution has started successfully. Now the Tkinter window has opened successfully. This is the Tkinter window showing the live video and the mask reduction log above. First, I'm going to select the video file, mask video mp4. Then I'm going to click start. Now the model inference has started successfully. Now it is processing a video frame displaying the mask status and the mask ID. On the display information in the Tkinter log tab, you can see object IDs 1 and 2, the date and time, mask status, mask, the mask image path, and the mask image. Then there's the download option. You can then download the mask detection log as a CSV file. The model has successfully processed all the video frames and generated the output mask and mask ID. Next, I'm going to stop the execution. Then I'm going to provide another set of input here, which is no mask. First, I need to run py inference. Now the Tkinter window has opened, and I'm going to select a video file that has no mask. No mask. Then I'm going to click start. No mask. Mask ID is 1. I hope you were able to understand everything from my explanation of the project and how to run the code. If you have any questions about the project or the code explanation, please share your thoughts in the comment section. I'm ready to help you. Thank you.
Hope you enjoyed the course. Course will surely give you solid foundation in computer vision, and then it will help you on your final year projects also, and then surely it will help on your cracking your job interviews. While implementing this project, if you face any kind of difficulty while implementing the project or while setting up an environment, or if you get any kind of doubt, you can feel free to put in the comment section. We will surely will help you in as soon as possible in a better way. Thank you.